Okay, now that we've looked at the basics and really gotten a summary of sequences and series so far, now we're going to move to arithmetic progression. Arithmetic progression is the first type of sequences that we're going to look at. The main thing about arithmetic sequences is that they have a certain constant difference between each term. To find this difference d, all you have to do is subtract two consecutive terms. This is the defining factor of an arithmetic progression, and any sequence which does not have a constant difference cannot be an arithmetic progression. This might seem like a general fact, however, in the NET, you'll be given a certain sequence which you'll have to identify whether it's an arithmetic, geometric, harmonic, or a Fibonacci or any other sequence. And for that purpose, you need to have defining characteristics through which you can eliminate certain options. Okay, now we're going to look at the formulas that you're going to need for the NET. In the NET, for sequence questions, you're going to have you're going to be given a series, and then you're going to be asked to find a certain nth term in that series. For that, in arithmetic progression, we have a formula an is equals to a naught plus n minus 1 into d. That is the most basic formula. Afterwards, we have the formula for series. If you recall, series is the summation of a sequence. So for series, we have two formulas. One can be converted into the other. But for saving time, we're going to look at the first formula, which is when you have not been given the last term of a finite arithmetic sequence. When you are given the last term, we're going to look at the second formula. Again, keep in mind, in the NET, the two most important things are maintaining time, because you'll be given less than a minute for each MCQ. 200 MCQs in 180 minutes in the NET. And the second thing is to not be confused in which series that you or which sequence that you're looking at. It's an MCQ based assessment, so elimination is going to be your best friend. Eliminate two of the options, then out of the two remaining options, make an educated guess if you're very unsure, or apply formulas to the last two remaining options. If you look at the entire question as a whole and try to solve it step by step completely, you're not going to be able to have enough time to solve all 200 of the MCQs. Okay, another major type of sequence which I would give more precedence to than arithmetic is geometric progression. In geometric progression, the core concept is that there is a common ratio that you can multiply to each term to get the next term. To find this ratio r, you will simply divide any term with the term previous to it. A certain formula for this, for finding any term in the sequence, is an is equals to a naught r raised to the power n minus 1. Something that confuses students regarding geometric progression is the value and the sign of r. If you are getting a common ratio in the negative, then we're simply going to take a modulus, because the actual concept of how the series behaves, whether it's infinite, finite, divergent, or convergent, actually depends only on the modulus of r. So we're going to ignore the negative sign and only focus on the modulus of the common ratio. Again, keep in mind that you cannot solve the entire questions. You will not have enough time. So use proper approximation. If you've been given a question to find the sum of a series, may it be geometric or arithmetic or any other, you can simply reduce the number of options from 4 to maybe 3 to even 2 by simply getting a good approximation of what that sum should look like. Okay, now here's the time I'm going to introduce the sum of geometric series. We can have two types, finite and infinite sum. For a finite sum, the common ratio must be greater than 1 and not equal to 1. And for the infinite sum, the common ratio must be less than 1. Again, the modulus of the common ratio is what we're talking about here. Certain tips that helped me get a grasp on geometric series was just simply getting to know the nature of the series. If you've been given a sequence or a series, and a geometric sequence or a series, and you want to know whether it's divergent and convergent or finite or infinite, just being able to figure out what it actually is will tell you a lot about the nature of the solution. So you don't actually have to find the solution, you just have to understand what it would look like. Try to find one of those similar looking answers in the number of options that you've been given out of the 4, and that will allow you to select the right option most of the time. Now let's look at some honorary mentions. First of all, we have the harmonic progression. It is simply the reciprocal of the arithmetic progression. From the formulas to the common the constant difference. It is simply the reciprocal of the arithmetic progression. Then we have the alternating sign progression. In the alternating sign progression, we must keep in mind that it is an infinite progression. The sum of an alternating sign series leads to infinity. And then lastly, we have a mixed progression. It could be a sum of arithmetic progression and geometric progression, or any other combination of other progressions. To solve these types of series, keep in mind that you have to separate, first of all, identify all the series that constitute it, and then separate them and then solve them individually. However, the NED does not include them in such detail that you will be needing to study them intensively. But मैं ये कहूँगा कि दिमाग में रखिएगा कि जब इस तरह की कोई ऐसी काफ़ी complicated series आ जाती है, so there's a high probability कि it's a mixed variant. That's it for this lecture. Next, we're going to move on to arithmetic mean, geometric mean, and harmonic mean. So stay tuned.